Now I want to talk about any normal distribution. Remember, the standard normal had mean 0, standard deviation 1, but now we can have normal random variables that do not have those values for the mean and standard deviation, but we can apply the same general principles. So for example, suppose the height of giraffes, x, is normally distributed with mean mu equal to, say, 17.3 feet and a standard deviation equal to 1.5 feet. So questions can be asked about probabilities here using the normal distribution curve and normal CDF. So for example 1A, find the probability, say, that the height of the giraffe is between 14 and 18 feet. So I can draw a picture of this situation. So it's the same curve as the standard normal, but now the mean is in the middle. So when it was a standard normal, the mean was 0. Now the mean of this was 17.3 is in the middle of this curve. 14 is lower than 17.3. 18 is bigger than 17.3. So this probability is represented by that area, which I can do using normal CDF. The low x is 14, the high x is 18. And now you have to enter the value of the mean and standard deviation. The mean is 17.3. The standard deviation is 1.5. And on the calculator, distributions, normal CDF, the low x is 14, the high x is 18. It defaults to the standard normal, but now we have to change those values. The mean is 17.3, and the standard deviation is 1.5. And when I go to paste, the probability that the height of a giraffe is between 14 and 18 feet is about 0.666 to 3 decimal places. We could also ask, using the same number, 17.3 and 1.5, I could ask a question like this. Remember the mean, this is part B of this, remember the mean was 17.3 and the standard deviation was 1.5. Find the probability that the height of a giraffe, say, is greater than 16 feet. Here's the picture. So remember, the mean is in the middle, 17.3 is in the middle. Now bigger than 16 means the 16 is the low value, the 16 is a little bit less than 16.3, and greater than 16, so it's all this area that we're talking about that represents the probability. And on the calculator, normal CDF, the low x is 16. It goes on forever and ever and ever in the positive direction. I'm going to enter 99999, 6 nines. And then the mean and the standard deviation is 1.5. And that comes out, normal CDF. The lower now is 16. The upper is 9999999. It's the same mean and standard deviation as what I just did. And it calculates the probability of about 0.807 to 3 decimal places. 0.807. Now we can also turn this around by asking a question like this, which you use InvNorm. I think they have a question like this in the homework. So for an example, suppose the length of pregnancies is normally distributed with a mean equal to 261 days and a standard deviation of 5 days. This time they asked this question: find the values that separate the top 5% and the bottom 2%, say. Okay, well, here's the picture that goes along with this question. So again, I'm going to start with a graph of a normal distribution. Here's a normal distribution. Remember, the mean goes in the middle, and this time it said the mean was 261. Now the top 5%, we'll call this, we'll start with the bottom one. So the bottom 2%, let's call this value x1, and the bottom 2% means that the area to the left of that is 2%. Well, that's 2%, which is 0.02. So that value along the x-axis is the separating value for the bottom 2%. And the top 5%, here's x2. And now this shaded area is 5% is 0.05. And both of these numbers can be calculated using InvNorm. x1 is InvNorm. Remember, InvNorm wants area to the left, so this time the area is 0.02. The mean was given as 261, and the standard deviation was 5. So on the calculator, I'm going to InvNorm. Area to the left is 0.02 for the 2%. The mean is 261. The standard deviation was 5. And when I hit paste, about 250.7, rounding that off to 1 decimal place. Now the other one, the x2, the top 5%, this time the 5% is the area to the right. Remember that the total area under the normal distribution curve is 1. So if 0.05 is the area to the right, then 1 minus 0.05 is the area to the left. Mean, standard deviation. Let me just do this one with the stat wizard off, because I don't think I did an InvNorm with the stat wizard off yet. So if I turn the stat wizard off, okay, now it's just not going to give me that menu. So if I go second, distributions, to InvNorm, it just expects that I know what the parameters are. So the first parameter is area to the left, which for this example is 1 minus 0.05, comma, the mean is 261, the standard deviation is 5, and when I hit enter, about 269.2 rounded off to 1 decimal place.